Good morning friends. Up to this we discussed about the phenomena of refraction and also the total internal reflection. Now in phenomena of refraction what's happened? When the ray of light traveling from one transparent medium to the another transparent medium, so its path is seen at the surface separating the two medium. Already we discussed this thing. Here there is the medium 1. That is the medium 2. Here the refractive index n1, here the n2. Suppose the n1 is less than n2. So in that case, when the ray of light is traveling from one transparent medium to the another transparent medium, so it is reflected at the surface separating the two medium. That means its path is seen. Instead of the straight line, there is the diverging by this slight angle. That means it bends towards the normal. In that case, the ray of the light is traveling from there to the denser medium. Already we discussed the phenomena of refraction. But if the surface separating the two medium is not a plane or a straight line, there is the curve. What's up? Now, today we are going to discuss the phenomena of refraction in which the surface separating the two medium is not a straight line or not a plane. There is the curved surface or the spherical curved surface. So in that case, how the phenomena of refraction take place, and in this case, we have to obtain the relation between object distance u, image distance c, radius of curvature, and refractive indices of the both medium n1 and n2. Actually, there is the concept of a lens. Lens has the two spherical curved surface. Here we consider the convex lens. Here, when the ray of the light is passing through the lens, it is reflected twice, one from this surface and second from the other surface. So we are going to start our discussion about the lens. For that purpose, first we discussed about the reflection by one spherical curved surface. What are the images formed by the first surface? This image is act as virtual object for second spherical curved surface, and final image is formed after the reflection twice, once by the first surface and second by the other surface. Okay. And due to that reason, for our discussion of the lens, we start first for the reflection by the single curved surface. And what is the relation between the U, V, R, and N1 and N2 are the refractive indices of a medium. For that purpose, first we have to understand what is the diagram for this type of the refraction, for the refraction at spherical curved surface. For that purpose, there is the principal axis, there is the surface separating the two medium, that is the spherical curve, and the surface is concave. Now listen, there is the center of curvature, there is the point N, there is the point N. Therefore, AC below the normal, or the rays will connect the N and C. So NC becomes the normal point of incidence N. Now there is the principal axis. Here we consider the point like object O. The incident ray coming from the point object O that makes the angle I with the normal. So I is the angle of incidence. Here the medium having the refractive index is n1, and here the another medium having the refractive index is n2. Here condition is that n1 less than n2. n1 less than n2. That means there is the rare medium and there is the denser medium. There is the denser medium. Ray of the light traveling from there to the denser medium. After the reflection, it bends towards the normal. So after the reflection, it bends towards the normal. This, and thus the image of point-like object is formed in the principal axis at point I. At point I. The second ray, which is incident at pole of a spherical surface, and there is the normal incidence take place. Therefore, after the refraction, it is also propagate along the direction of the axis or along the axis. Thus, the both rays reflected at meet at point I. Thus, I be the image of point-like object. Okay. Now, here the rays incident from the medium having the refractive index N1 and the reflected medium having the refractive index is N2. Okay. Now, as we do the normal flow N on the principal axis. So Nm becomes the normal. Becomes the normal on the principal axis. Now listen. Here the aperture of the spherical surface is very small, and also incident rays are partial. Incident rays are partial. Therefore, all this angle, and also this angle are very small. This angle is angle of incidence. This angle is angle of refraction. So that is our figure. Now there is the lens here. Now we discuss this figure. For that purpose, the figure shows the formation. Figure shows the geometry of formation of an image I of object on principal axis of a spherical surface of center of curvature C and radius of curvature R. Now listen, is the description of figure. Figure shows the formation of image I of point object O on principal axis of a spherical curved surface with the center of curvature R and radius of curvature is capital R. Center of curvature C and radius is R. Okay. Now there is the object distance minus U. There is an opposite direction of incident ray. Okay. Image is formed here. So there is the image distance. Okay. Here the rays are incident from the medium of refractive index N1 on the another medium having the refractive index of N2. The rays are incident from a medium of refractive index N1 to another medium of refractive index N2. Now, next is Nm is normal on the principal axis. Nm is normal on principal axis. Now here we make the assumption the aperture of the spherical surface and incident rays are partial. Therefore, all these angles are very small. Here, aperture of a spherical surface and incident rays are paired so that all angles are very small. Here is okay. Now after that, here you consider the one triangle. Angle are small and also PM is neglected. This distance is very, very small. We neglect this distance. Okay. Now, for triangle NOM, for triangle NOM, tangent of this angle NOM, angle NOM. But here, the incident rays are partial, therefore this angle is very small. So instead of the tangent, we can directly enter the angle NOM. Tangent of this opposite to the adjacent and M upon MO. But the MN upon MO. Clear? That is our first equation. Now, second triangle NOC. For triangle NOC, this triangle. Again, the tangent of this angle opposite to the adjacent. Angle NOM. Sorry, NCM. NCM. Your triangle is over NCM. NCM. Therefore, angle tangent of this angle MN upon MC. This angle is very small, so directly we can write there is the angle NCM. NCM is equal to MN upon MC. Equation 2. And for another triangle, there is the NIM. For triangle NIM, this triangle NIM. The tangent of this angle opposite MN upon MI. But this angle is very small, so instead of the 10, directly we can add tangent of angle NIM is approximate angle NIM is equal to opposite MN upon MI. Equation number 3. Okay. Now consider this triangle. So thus we obtain by considering the triangle NOM. We obtain the value of this angle. After that, NCM, we obtain the angle of this value of angle of this. And after this, we consider the triangle NIM. We obtain the value of this angle. After that, consider the triangle NOC. The angle of incidence I is an exterior angle. Again, for this triangle NOC, I is an exterior angle. Therefore, I is equal to the sum of these two angles. Sum of these two angles. This angle is NOM and this angle is NCM. So, for triangle NCO or the NOC, I is an exterior angle. Therefore, I is an exterior angle. Therefore, how we can add? I is equal to addition of these two angles. Addition of these two angles. Therefore, I is equal to angle NOM plus angle NCM. Therefore, I is equal to angle NOM plus angle NCM. Already we obtained the value of NOM and NCM from equation 2, 1 and 2. From 1 and 2, we substitute this value. Therefore, I is equal to NOM, Mn upon Mo, Mn upon Mo, plus angle NCM, Mn upon MC, Mn upon MC. With the equation 4, equation 1. So thus we obtain the value of I. Why we require the value of I? Because we are going to apply the Snell's equation n1 sin I is equal to n1 sin R, and thus we also require the value of R. For that purpose, here we consider the another triangle. This another triangle is NIC. For NIC triangle, this angle is an exterior angle. That means the NCM is an exterior angle. Therefore, NCM is equal to addition of NIM angle plus INC angle. But the INC is R. And for triangle, which triangle? NIC or the NCI. Angle NCM is an exterior angle. NCM is an exterior angle. Therefore, angle NCM is equal to addition of this plus this. Therefore, NIM angle NIM plus angle INC, this angle INC. But we know that angle INC is equal to angle of refraction R. Substitute here. Therefore, angle NCM is equal to angle NIM plus R. Therefore, R is equal to angle NCM minus angle NIM. Now, the value of NCM and NIM angle already we have in equation 2 and 3. NCM this, NIM is this. Therefore, from equation 2 and 3. Therefore, R is equal to NCM, Mn upon MC. Mn upon MC. Minus NIM, Mn upon Mi. There is a equation number R. So, thus we obtain the angle of incidence and angle of refraction. Okay. Now, after that, we require the relation between the object distance, image distance, radius of curvature, and the effective indices. For that purpose, we are applying the Snell's law at point N. Applying Snell's law at point N. Therefore, N1 sin I is equal to N2 sin R. N1 this medium, angle of incidence also in this. Therefore, N1 sin I is equal to refraction angle is in this medium having the effect index N2. Therefore, N2 sin R. But these two angles are very small. Therefore, N1 I is equal to N2 R. Substitute the value of I and R. Substitute equation 4 and 5. Therefore, what's the Here there is the N1 value of I is this Mn upon Mu plus Mn upon Mc is equal to into value of I is this Mn upon Mc. Mn upon Mc minus Mn upon Mi. Mn upon Mi. Now Mn is taken common, that is the cancel. Therefore, what is the meaning? N1 upon Mo plus N1 upon Mc is equal to N2 upon Mc plus N2 upon Mi. Now, substitute. What is the MO? MO is the object distance, that is our minus U. Substitute MO is equal to minus MC. MC is measured in this direction, that is in the same direction of angle of incident of ray. Therefore, there is positive. Therefore, MC is equal to capital R. And what is the MI? MI also measured in the same direction of incident ray. There is the image distance. It will show positive. Therefore, we obtain N1 upon minus U plus N2 upon R is equal to N2 upon R plus N2 upon Mi. Mi is equal to there is our N1. Therefore, minus N1 upon U plus N2 upon V is equal to N2 minus N1 upon R. And here there is the minus sign already. It is taken this side, that becomes the positive. So there is a required equation. Minus N1 upon U plus N2 upon V is equal to N2 minus N1 upon R. There is the required equation. It shows the relation between object distance, image distance, effective indices, and radius of curvature of the spherical surface. This equation is only valid for when the ray of light is traveling from ray medium to the denser medium. This equation is derived for a ray traveling from medium N1, that means the ray, to the medium N2 denser. Here is there is totally mathematical, so if you write one or two times at that time you can get it, because here the importance of this angle. And also we have to use the concept of the exterior angle and substitute the value of I and R in equation of Snell's law. Okay, just begin the relation for the ray traveling from the medium of refractive index N1, that is the ray medium, to the denser medium of refractive index N2. This relation is the relation between this minus N1 upon U plus N2 upon V is equal to N2 minus N1 upon R is derived for a ray traveling from ray medium having the effect index n1 to the denser medium having the effect index n. Now, opposite to that, when the ray traveling from denser to the medium, that is for that case n1 less than n2. This is now, if the travel from denser medium, then the effective index is into 2, ray medium having effective index is n. Now your condition is the n2 is greater than n1. This relation is obtained by replacing n1 as n2 and n2 as n1. Therefore, our equation is minus n2 upon u plus n1 upon v is equal to n1 minus n2 upon r. Here n1 n2 interchange. Therefore, there is the minus n2 upon u plus n1 upon v is equal to n1 minus n2 upon r. This relation for the ray traveling from denser to the ray medium. And here the condition is that n1, n2 is greater than n. That is the condition. Clear this? So keep in mind that when we are using this equation in numerical, at that time the ray traveling from which medium to which medium. So there is be careful about that. Otherwise, our answer becomes the wrong, either positive or negative. The sign becomes the wrong. Clear this? Okay.